All right, let's go ahead and get into this next section of notes here. So today we're in 9.4 and we are talking about trig functions. So remember at the very beginning of this unit, we labeled this trigonometry. So now finally, after going through some of the basics with right triangles and radicals, we're actually getting into the heart of this chapter, which is talking about trig functions. So day today is the first. An objective for today is we're going to be able to use trig functions in order to find side lengths in these right triangles. Okay, so first off, what does that mean if I say the word trigonometry, or what is that referring to? Well, trigonometry is, we'll just call it this, we'll just say the study of side lengths in right triangles. Okay, trigonometry is just the study of side lengths specifically in right triangles. So that's why we spent so much time with these chapters leading up to it, to learn and kind of refresh on some of the things that we talked about with right triangles involving Pythagorean theorem and then special right triangles. Okay, so biggest thing that you need to know from this is going to be something hopefully that you remember past high school as well, is this memory device that we have for using trig functions. And so this is what we call SOHCAHTOA. And you need to spell it like that. It's SOH-CAH-TOA. Okay, this is SOHCAHTOA, and this is the way that we can remember how to use trig functions. So, and we'll write that as the definition first, is we'll just say memory device for the trig functions, okay, or the trigonometry functions. And there are three total that we're going to be looking at. These three you might have seen kind of on your calculator if you have a more advanced calculator. But there's three trig functions that we're going to be talking about and then we'll use in this class and then next year in Algebra 2 as well. So those three functions are sine, cosine, and tangent. These are the three trig functions that we can use. And this is what this memory device is going to serve us for, is sine, cosine, and tangent. And I'll add this little piece on it as well. We'll say the functions. Okay, what are those functions? We'll say the functions represent the ratios. Okay, each of the functions represents the ratios in we'll say with sides of a right triangle. Sides of a right triangle. Okay, so anytime we bring those up, if I see those words sine, cosine, and tangent, what is it referring to, or what does this help me do? It helps me find the ratios with the sides of a right triangle. Okay, so how SOHCAHTOA works, or what this memory device is we have one for sine, one for cosine, and one for tangent here. So sine, we abbreviate as SIN. This is what we call sine. It's just an abbreviation. And sine of, we'll just say x, is always going to equal the opposite side over the hypotenuse. Okay, and we'll obviously do an example with this here in just a second. But sine is always going to be opposite over hypotenuse. And how do we remember that? Well, we have this here in the why we spell it SOH is because we have sine opposite over hypotenuse. So that's what all those letters stand for there. Okay, which means if we're looking at the next part, ca, if I have cosine, we abbreviate that as COS. Okay, COS, and we'll say cosine of x is always going to be the adjacent side over the hypotenuse. Okay, and we know what the word hypotenuse means. We've seen that a bunch. We'll talk about what opposite and adjacent are in this context here in our next example. Okay, but cosine, or ca, is adjacent over hypotenuse. And then lastly, tangent. You might be able to guess if it's TOA, tangent of x, that means it's going to be O over A, so opposite over adjacent. Okay, make sure you have these three things written down in your notes. We're going to be looking back to them and using them a lot when we're trying to solve for different side lengths in these pictures here. We have sine, cosine, and tangent. Tangent we abbreviate as just TAN, and that's going to be opposite over adjacent. Okay, so what does all this mean? What are we talking about now, and how can we put this to use here? Okay, if you'd like to, I want you to take a sec, pause your video, and sketch this diagram for me here. So we have this right triangle. We have side lengths 8, 15, and 17. And if we are really curious, we could plug those into the Pythagorean theorem and make sure they come out to be correct, and they will. Okay, so first thing it's asking me for is it's asking me for the sine of p. So I'm going to write this out, sine of p here. So I'm focusing on this angle. Well, if we scroll back up and we're thinking of SOHCAHTOA, we said sine, or SO, is going to be opposite over hypotenuse. So when I'm setting up a ratio here, I'm going to look, I have 3 sides to choose from. One side that's opposite of this angle, one side that's adjacent to this angle, and then one that is just the hypotenuse of our triangle. So how do I figure out which ones I'm going to use? Well, that's where we said sine is going to be opposite over hypotenuse. So the opposite is 15, so I'll say 15. And then hypotenuse in this triangle is going to be 17. So sine of 15 over 17, and this right here would be basically my final answer. Okay, if I wanted to, I could type this into my calculator and get a decimal, or if we have a situation where I can simplify the fraction, then I'll do that as well. Okay, but in this case, sine of p is going to equal 15 over 17. That is the ratio that we have between those two sides. Okay, next one here, it asks us for the cosine of p. So I'm going to say cosine of p here. Again, focusing on angle P here, and this time if we scroll back up, we said cosine is going to be adjacent over the hypotenuse. So the adjacent side, the one that's right next to P, is 8. Okay, the hypotenuse is technically also right next to it, but that is its own side in itself. That's always just going to be the hypotenuse. Okay, so the adjacent side is 8, and then the hypotenuse is 17 again. So this is 8 over 17, and again, that would be my final answer here. When it's asking for these functions, it's asking for a ratio. So the ratio of these two is 8 over 17. All right, and then last function we have here, the tan of q. So I'll go write this in, tan of q. Okay, and if I want the tangent of q, this time we're focusing on the other side. We're focusing on angle q here. So our opposite adjacent might just change a little bit. So again, we look at tangent. We look at up here, we said that's opposite over adjacent, the TOA part, right? So the opposite angle of Q is 8. So I'm going to say opposite on top, or 8 on top. And then the adjacent side to this angle is actually 15. And like we said before, the hypotenuse is technically adjacent as well, but the hypotenuse is always just going to be that. It's always just going to be the hypotenuse. Okay, so this would be 8 over 15. Again, I can't simplify that, so that would just be my final answer. Okay, this is how trig functions work. We want to find ratios of these sides here. How are these sides going to relate to each other in a fraction? Okay, another example with this. We can actually find the sine, cosine, and tangent of angle measures, or degrees. So example 2 here, I want you to take a second, I want you to sketch this diagram. So we have this right triangle with 12 root 3, 36, and 24 root 3. Okay, I'm looking at this one here. First thing it says is I want to determine the measure of angle L and angle J, and then I want to find the sine, cosine, and tangent of each of those angles. So if I'm looking at this here, the first part is a little confusing. It says I want to find the measure of those two angles, L and J. Okay, well I know they're going to add up to 90 because this is a right triangle, and all of them should add up to 180 total. Okay, but if I want to figure out what each of them are individually, we haven't talked about a method to find the angle here. But we can actually use a pattern that we just talked about in our last notes. Okay, remember we see this here. If we see this, this could be our shortest leg, and this could be A, which means if I look at my hypotenuse, I notice 12 root 3 and 24 root 3, that's just double it. So that would be 2A. And then if we had to double check, we could guess, or we could plug this in on this last one here and make sure this comes out to be correct. But this is actually going to come out to be A square root of 3. Okay, if we're using those terms. Okay, so what does this mean for us? Remember we talked about side lengths with these ratios here. This is what we have as a 30, 60, 90 triangle. Okay, the 30 would go down here in the bottom right, and then J, that would make it 60 degrees over here because you want 30 degrees across from your shortest leg. Okay, so now we've found the first part. Find the measures of L and J, that's 30 and 60. So this is a 30, 60, 90 triangle, and now I want to find the sine, cosine, and tangent of each of these. So I'm going to go ahead and erase these extra marks so they can We don't have to worry about those. So I want the sine of 30, the cosine of 30, and the tangent of 30. Okay, notice on the last ones, we said the sine of, p, just some random angle. Now we actually know the angle here. Okay, so I want the sine of 30 here. And this is something that we can just use our ratios for. So again, if we're thinking of SOHCAHTOA, again, I can write this up at the top if we've forgotten. Okay, sine is going to be opposite over hypotenuse. So in this case, if I'm looking at 30, the opposite side is 12 root 3. And then over the hypotenuse here, the hypotenuse is 24 root 3. Okay, and now how could I simplify this down a little bit? Well, if I look at this here, the root 3's are on top and on bottom, so those should just cancel each other out. And now I'm just left with the fraction 12 over 24, which hopefully we understand what that simplifies down to. That's just the same thing as 1 over 2, or 1/2. Okay? And this is good. If you type this in your calculator and your calculator is in the right mode, and I type in sine of 30, that's always going to come out to be 1/2. So again, this is a ratio. So what this means is that anytime I have an angle here that is 30 degrees, the ratio of the opposite to the hypotenuse is always going to be 1/2. Okay, in other words, this side will always be half the length of the hypotenuse. Okay, every single time. No matter if the triangle is really big, really small, different side lengths, still going to have that ratio. Okay, cosine of 30, next here, again, we're looking at SOHCAHTOA. That's going to be adjacent over hypotenuse. So now the adjacent side is 36 here. Okay, over 24 root 3, because again, that's the hypotenuse. And we want to simplify this. First thing that I would do to simplify this is look at the fraction. So I see 36 over 24, and hopefully we notice that 12 goes into both of those numbers. So if I divide that out, on top I would be left with 3, and on the bottom I would be left with 2. So this is the same thing as 3 over 2 root 3. Okay? And then like we've said, one other thing that we need to fix with this is that we cannot have a radical in the denominator. So we use our little trick here. We can multiply by top and bottom by that square root. So when I multiply those here, I'll try to save on space, and we'll just do this all in one step. This is going to be 3 square root of 3 over, okay, and then on the bottom, the square root of 3's multiply together. Square root of 3 times square root of 3 is 3. And then I also have a 2 down there, so 3 times 2 is 6. So I have this here, 3 root 3 over 6. And one more step that I can do, I can simplify that fraction. 3 over 6 is the same thing as 1 over 2. So this is 1 root 3 over 2, or in other words, square root of 3 over 2. Okay, and I know I'm kind of losing some space here for our next one. We'll just push that over to the side. Okay, but this is going to be square root of 3 over 2. All right, and then last one here, tangent of 30. Remember, tangent is opposite over adjacent. So opposite is 12 root 3. Adjacent, like we said, is 36. So just like before, I can actually simplify this one as well here. When I go to find this, 12 over 36, that's the same thing as 1 over 3. So this is square root of 3 over 3, if I simplify that down a little bit. Okay? So notice that here, square root of, it's really 1 square root of 3 over 3, but to keep it simple, I can just write square root of 3 over 3. Okay, now I want to find the sine, cosine, and tangent of the other angle in this picture, which is 60. Okay, sine of 60, cosine of 60, and tangent of 60 here. Okay, and I'll circle these 3 answers. These are my 3 that I had. Okay, if I want the sine of 60, again, it's opposite over hypotenuse, except this time the opposite is a little bit different. Okay, the opposite is 36 now, and then the hypotenuse hasn't changed. That's still 24 root 3. Okay, and like I said, we've actually already seen this. We saw this with cosine of 30. We saw the same fraction, which means I'm not going to do the same steps. I'm just going to write the same answer, square root of 3 over 2. Okay, so notice the sine of 60 and the cosine of 30 are the same thing, because in that case, we're still putting the same 2 sides over one another, except in one of them, it's the adjacent side, the other, it's the opposite side. Okay? Cosine of 60, we're going to notice the same kind of pattern here. We want adjacent over hypotenuse. The adjacent now is 12 root 3, and the hypotenuse is still 24 root 3. And just like I've said, we saw this already. We saw this when we had sine of 30, and that's also going to be 1/2 when we simplify. So you'll notice this pattern. If you have two angles in a right triangle, the sine of one of those angles is always going to be the same thing as the cosine of the other angle, because you still end up putting the same two sides over one another. Okay, we just have different names for them depending on where the angle is. Okay, and the last one here, tangent of 60. This one is going to be a little bit different. Our opposite side in this case is 36, so we're going to put 36 on top. And the adjacent side, because we're thinking of TOA, that should be opposite over adjacent. Adjacent side is 12 over square root of 3. So this time it's just kind of the reverse of the one that we had with tan 30. So 36 over square root of 3. Again, this can be simplified down. This is just the same thing as 3 over 1, or in other words, 3 over, in this case, just square root of 3. And like we said, we don't want to leave it like this. We want to make sure that there's no radical in the denominator, so I need to use that trick. I need to multiply by square root of 3 on both sides, or on top and bottom, I should say. Okay, so on the top, I have 3 square root of 3. On the bottom, I have square root of 3 times square root of 3. The little shortcut that we use, that's just 3. And so final answer here, 3 on top, 3 on bottom, cancel each other out, and this is just square root of 3. Okay, so these are my trig functions, and these are actually very common ratios that you're going to use later on. Okay, there'll be times when you'll work in Algebra 2 and you'll have to find the sine of 30. Your calculator can do all this for you, but I want to make sure that you understand why we get these answers. Okay, and like I said, you'll go more in depth next year, but just keep this in mind. This is how you set up these ratios. Make sure you remember SOHCAHTOA. Okay? All right, a few more examples here, practicing this. Why is this so important, or why are all these ratios helpful? Is because I can actually now use this to find some different side lengths. So we've talked about using or finding a side length if we just have one of the or two of the sides using Pythagorean theorem. Now all we need is one of the sides and one of the angles, and we can let the trig functions in our calculator do the rest here. Okay, so take a second if you need to sketch these triangles for me. I need to get my calculator out here. Okay, I want to set up trig functions to find these missing angles. Okay, and these are going to come out to be decimals usually. So how this works here is, first thing I want to do is I look at the angle that I have, and I want to identify the two side lengths that I've been given, whether it's a number or whether it's a variable. So if I'm looking at an angle of 27 here, if I look at x, x is the adjacent side in this case. So I'm going to go ahead and mark that, adjacent, the adjacent side. And then 19, we know how to label that. That's always just going to be the hypotenuse here. So if I have adjacent over hypotenuse, I'm thinking of what trig function that goes with. And remember, that would be ca, or cosine. So I'm going to say cosine of the angle, whatever angle I have. In this case, we're looking at 27. I'm going to say cosine of 27 equals, and if we're thinking back to how we use that memory device, adjacent over hypotenuse. So x over 19. So this is how I would set up the equation. Cosine of the angle is always adjacent over hypotenuse. So cosine of 27 is x over 19. And now we can actually solve this here. We're trying to solve for x, or we're trying to get it by itself. So I would make sure you simplify it first and get x by itself, and then you can let your calculator do all the work, because I'm not expecting you guys to know what this is. This is going to come out to be a very weird decimal, and we'll see that in just a second. Okay. Here's how we want to get x by itself, though. I see x is divided by 19, so I want to do the opposite. I want to get rid of that by multiplying both sides by 19. So when I do that over here, these cancel, leaving me with x, which is what I wanted. And on the right side, I'm just going to write this out. I'm not going to change it or anything like that. This is just 19 times the cosine of 27. Okay, like I said, the cosine of 27 is not just a simple number. This is something that your calculator, or you're going to need your calculator to do. And you can do this either on your iPhone or on a calculator that you have. So you want to find the cosine button. If you're on an iPhone, then you're going to have to type in the number first. But you want to type in 27, or in other words, the cosine of 27. So if you're on a calculator, just type in cosine and put 27 in the parentheses. If you're on your iPhone, type the number first, turn your phone to the side, and then hit the cosine button. In any case, this should come out to be a weird decimal. It's going to come out to be, the 19 is going to stay the same. This will come out to be something like 0.891 and then a bunch of other stuff. Okay, but it should be positive. If it is negative, then your calculator is in the wrong mode. It's in radians, and you need to change it to degrees. And that is really something that I'm just going to have to help you with individually if your calculator is not in that mode yet. Okay, if it's on your phone, I can show you how to do it quickly. If it's on your calculator, I can show you how to do it quickly as well. Okay, but that's not really something I can explain how to do over the video. Okay, but just know you should get this decimal here, and it should be positive. Okay, and now we have this decimal. We want to keep that in our calculator. We don't want to change anything, and now it just says we need to take that and multiply it by 19. So I multiply that by 19. Again, your calculator should spit out a long decimal, and this is going to be about roughly 16 points, and I'll just round it off to the nearest tenth. We'll say 16.9. And this is my final answer here. So notice before, if we were just given one angle and one side, we couldn't find what another side length would be. But now that we have trig functions, we can actually use that to solve for some different lengths. Okay, so just another way or another route that we have to solving for different lengths. All right, last one here, practicing this a little bit more. Again, I see a triangle. How am I going to use trig functions to set this up and solve this? First thing that you need to do is identify which two side lengths you have in terms of opposite, adjacent, or hypotenuse. So if I'm looking at the angle that I'm given here, okay, I see this is 24, and that's opposite of it. So I'm going to go ahead and label that opposite. And then x here, this one's always easy. This is just the hypotenuse, right? Okay, notice sometimes x will be one of the adjacent sides, sometimes it'll be the hypotenuse, just depends. Okay, so we have this here. If I'm looking at opposite and hypotenuse, I can think back to SOHCAHTOA and figure out which trig function I would need to use here. Okay, in this case, that would be sine. So I'm going to say sine of the angle, so sine of 61 equals here. Okay, and in this case, you're just going to have to do opposite over hypotenuse, right? The SO part of SOHCAHTOA. So 24 over the hypotenuse x. Notice the big difference here. This time, x is not on the top, it's on the bottom. So when it's on the bottom, it makes it a little bit tougher. So here's a little shortcut that you can use, because we can't just multiply by the bottom, because x still won't be by itself. If I want to get x by itself quickly, here's a little trick. If you have a fraction like this, you can just swap the place of these two things. Okay, you could do this in multiple steps, but I'm just going to do it in one step to save us on some time here. I can just swap the place of these two. So this is the same thing as saying x equals 24 over sine 61. Okay, that is our trick if x is on the bottom. We just swap it with whatever is on the other side of the equation. X equals 24 sine of 61. This will give you the same answer. Okay, now that I've got x by itself, I'm going to type this into my calculator here. Okay, if you have a technical calculator or a graphing calculator, it can keep these values in there for you. If you're just on your phone, then you're going to need to find the sine of 61, and then you're just going to have to write that decimal down and divide. And so here's what I'm going to do. I'm going to go on my phone here. I'm going to type in 61, and I'm going to hit the sine button, and that's going to spit out this decimal 0.87. So I'm going to say 24 over, and to keep it as close to the right answer as possible, I'm going to go to 3 decimal points here. So it spits out a decimal when I round it off to about 0.875. Okay, I need to write this down because my calculator on my phone can't hold that decimal in there. So now all I need to do is just need to divide here. So I'm going to go 24 divided by, and I'm going to do 0.875, that decimal that I found that I'm going to round off. Okay, and that spits out here, x equals 27 points, and then again I'll round it off. That's going to be 27.4 roughly. Okay, your answer should be somewhere around here. Okay, and I know this answer makes sense because remember the hypotenuse is always the largest side. So I know it had to be larger than 24. In this case, it comes out to be about 27.4. Okay, this is how we use trig functions. They're actually not too bad. It just takes some practice. Okay, so if you're a little confused right now and you're still struggling a little bit, that's okay. You know, it really just takes practice, and it just takes some time being able to use your calculator to do these kinds of problems. Okay, but now we can find a bunch of different side lengths just using these functions. Okay, so homework for this lesson is 9.4, trig functions. As always, if you guys have any questions, feel free to let me know. All right, thanks guys.